Okay, now, the last thing we're going to deal with significant figures, well, the last thing we're going to talk about significant figures, so we're never done with significant figures. For the rest of your science career at Riverdale that involves mathematics, we're always going to deal with significant figures. But the last topic deals with how we calculate with significant figures. How do we represent the answer that reflects the worst measured number? Because again, we're dealing with the weakest link rule, which we'll talk about again in just a little bit. So the problem that we had yesterday was this one in which we had 6.4811 centimeters on one side and 3.44 centimeters on the other side. Crunched all the numbers together, and we got this ugly looking thing, 22.29489 centimeters squared. Then I said, oh, well, that was wrong, even though you did everything correctly. So what was the issue? Significant figures. We use significant figures to figure out how many significant figures we should have in our final answer. Well, we said in the previous discussion that we had 5 significant figures here. We got 3 significant figures here. We should then reflect the worst of the two, which is the one that has the fewer or fewest, depending on how many numbers you have, significant figures in the answer. Since this has 3 significant figures, then we have to round this off to 3 significant figures as well to represent the weakest link. So the third significant figure is determined by starting at the farthest left and going backwards until you get to the number of significant figures you want to end up with. So 1, 2, 3, we come to this 2 right here. Now we use the rules of rounding to leave it the same or kick it up to the next higher value in that decimal place. Well, since 9 is definitely greater than or equal to 5, this is going to kick that up to a 3. Now, we're not going to put zeros after that because those zeros are going to make that number keep the same number of significant figures it has right now. We want only 3. So we're going to change that to 3, make that 22.3 centimeters squared. Okay? So this is the correct answer right now. Again, notice that no zeros are added to the end. You would if it's a whole number, but not if it's going to be past the decimal point as a decimal. Example, find the volume of a cube that is 0.045 centimeters on a side. Now, how do you find the volume of a cube? Well, a cube is a box in which all the sides are the same. Now, in a box you find length times width times height, but since the length, width, and height of a cube are all the same thing, we just simply say it's side cubed, S cubed. So, V equals S cubed is the formula we're going to use, so that means we're going to put in 0.045 centimeters to the third power. And this is the number that your calculator may give you. Now, I will tell you that it may give you something else. So let me put that up there, what you may be seeing instead. So while I'm doing this, you can go ahead and punch that in the calculator and see which number you get. Four zeros. Okay, so E negative. Your calculator may be giving you this answer instead. Now, if it gave you the regular answer, then no real issues. Well, I will tell you this. And this is, I think I had centimeters for this. If I remember correctly, I can't remember. Yeah, it's centimeters. So this is the cubic centimeters. Now, even though we're going to get into the scientific notation later on, your calculator, again, does this to save space. Look at all the zeros that we've got here, and look how many, we actually have less symbolism used in describing the number this way than we do this number right here. This is actually a shorthand form for this answer. Okay? Now, what that means is that it's a really small number, just like we got there. The negative exponent tells you that the decimal point has been moved 5 places smaller. And when you write an answer, I don't want this. This is computerese language. The computers used this first, then the calculators picked up on it and did the same thing. I don't want that. I want you to understand what it means and then put it either this respect or this respect for right now. Question I have to ask you though is what number of significant figures does that measured number have? Well, the doubtful digit is the 5. The 0 here is a placeholder because there's no other numbers between the 0, or around the 0, I should say. And so that means that this is going to have 2 significant figures. And how many significant figures should the answer have because of this? Well, the answer is 2. Okay? Because that's the least number of significant figures we have in a measured number, 2. So, if we use this number right here, we can round it off very easy. I mean, this is why I really like scientific notation, because it really simplifies a lot of things. This is number 1, this is number 2. So this is going to be your doubtful digit. The number next to it is a 1, so it doesn't change. The 1 here, so that becomes 9.1 times 10 to the -5th cubic centimeters. Now, if you don't like that, you want to keep this one right here, keep this in mind. These 4 zeros right here are placeholders. They are not part of the significant figure. So the first significant figure we have here is that one. The second one is this 0 right here. It looks like I forgot to put a 1 there. Just kidding. Right? So that's going to make that the doubtful digit. The number next to it is a 1. That's going to keep the same. So we could write that as 0.000091 centimeters cubed. You could write it like that, especially if you like zeros. Ooh, Mr. Campbell, I like zeros. Can I draw some more, please? Anyway, so we have here a way of representing numbers in 2 different ways, and I don't care which one you use. There may be, in the next couple lessons we got coming up, we're probably going to get into scientific notation and how we can represent that, in which case I may ask for strictly scientific notation in some cases, and regular numbers in other cases, so you can be able to do both. But the bottom line is, keep the weakest link rule in place. Whatever the lower or lowest number of significant figures happens to be in the setup of the problem, that is how many significant figures you're going to have in your answer. So, your practice problems, there's 5 of them. And then we in your script right there, there's the first 4 right there, and then the 5th right here. And make sure you have the correct number of significant figures in your answer. All right? Good luck.